Today's main topic is this one, easy and lazy technical writing and presentation. That will help you make yourself easy and lazy, but you will have very high quality paper and presentation if you follow what I'm going to talk about. So when you read some technical writing books and when you hear presentations, most of them tell what you should do. That's true. So it's worth reading, it's worth attending those lectures. However, as far as I know, most of them do not tell you each step. That's missing. So I'm going to tell you the steps you can follow to efficiently prepare your paper or presentation in the best possible way. Okay? So I understand most of you, or maybe all of you, are students or at least performing research at the university. So you have a boss, you have a professor. Ask them how you can write a good paper in the most efficient way. It's not that easy to answer your question. They know how to do it, but telling you how or teaching is something else. You need experiences, you need practices. I have hosted 80 internship students. I have collaborated with them in my career. So I had many chances to tell them how they can prepare a good draft, how they can prepare a good presentation. So sometimes, or I would say in most cases, your bosses or your professors don't know what is the good way. Well, at least they don't know how they can tell you their secret. So that's why it's worth being here for my lecture. All right? So I just skipped these things because of time constraint. And these are the contents. The highlight of my talk today is this place, the key to success by three-point analysis. How you can be successful. The key is to perform three-point analysis. And I'm going to spend some time on this part. I will skip most of these things like structure of a paper, because you can read about these things in the book, or you can attend the presentation. Let's see. I will also talk about how you can prepare a good slide. Okay? My slides are some examples. For example, the screen here is much smaller than usual. That means the slide looks very small. If you are sitting at a long distance in this room, for example, it's not easy to read these things unless you have you use a big font. So that's one of the things I'm going to talk about. And this is a proof, okay? Because I'm always using a font size larger than or equal to 24 point. It should be possible for the people in the last row to read my slide with this distance. Okay? So efficient paper writing, as I said, technical writing books, you should read some and then learn what. Okay? That's the first thing, minimum thing you should do. And then what I have been saying is, don't start writing a paper. Before writing a paper, before drafting, try to prepare slides, just like you are going to present something. Okay? So there are some reasons. In slides, I would recommend you are going to use font size which is larger than or equal to 24 point, so that you will be able to eliminate redundancy. Otherwise, you cannot put everything you want in a single slide. Okay? So this is a secret. And then you will be able to highlight the points. That's one of the benefits to use slides. But there are, of course, some. For example, when you would like to modify the structure of your talk or the flow, technical flow of your paper, it's very easy because you can simply exchange the order of slides. So that's another benefit. All right? logical structure is very important in a paper or in a presentation like this. So logic is very important, but you may wonder, what is a good logic? You may not be able to find a good answer to a question, what is a good logic in technical writing or technical presentation? Here are my answers. The first thing, it is easy to follow. That means you don't have to stop on the way. You don't have to give you a question what it really means. Okay, that's one answer. You can also think about it this way. It is possible to predict the next content. You can naturally predict what comes up next if the logical structure is good and natural. These two explanations are what I obtained during the course of collaboration with the students. If I explain in these ways, it was easy for the students to understand what is a good logic. Okay, so let me talk about slide first. You need to assign pages because there are many pages. You will not use only a single page of slide. You will be using multiple slides, typically 10 to 15 pages. All right? So sometimes it's useful to use a template when you have some. I have some templates in my presentation, but probably I will skip it because of time constraint. All right? Establish a good problem-value pair. This is really, really important, but in many papers this is missing. So when you have a chance of reviewing or reading other papers, try to understand what is the problem solved in the paper and what is the value, what the paper gives you, what is the advantage to read that paper. They should make a good pair because the paper is to tell the value, which is just opposite to the problem, but it is often not kept in a good way in many papers, especially in those written by unexperienced people. So pay attention to a good combination of a problem and a value, which are presented in the paper. You will first select figures and tables so that you will arrange a backbone of your presentation of your paper, and then you can fill in necessary information in each page. Balance slide allocation and also within each slide, and then sometimes you need to reorder slides to modify the logic, but it is performed very easy if you start writing something with slides instead of drafting a paper from the beginning. Sometimes paired words for the value problem pair help. For example, on the left-hand side, I am putting words to represent drawbacks or problems. On the right-hand side, I have opposite words to the ones appearing in the left-hand side. So that means on the right-hand side, I have good words or advantages. Okay, so these are positive words for the value. You may use these words to describe the value, and also by using the words on the left-hand side, you can describe negative points of the problems which reside with usually the conventional or the existing method. Of course, these words are used in my field of research, so it is recommended that you will make your own pairs by reading related papers. Okay, it's important. Now let me talk about page allocation. First, you need to assume how many pages you have, how many slides you can use. In presentation, when you are experienced, you can present 1 page per minute, but no more than that. So when you are given 30 minutes, you are not supposed to bring more than 30 pages in general. Okay? So usually the presentation, for your presentation, you are given 10 to 15 minutes, sometimes 20 minutes. Let's assume 10 to 15 pages, but we should be more specific to talk about it. So let's assume that you have 10 minutes, and then you are naturally going to prepare 10 pages in slides. Now, the first page is to describe the background of your research. The second page is devoted to introducing the conventional method or the state of the art. All right? Page 3 should tell the problem of the conventional method. In page 4, you are going to point out what is the point of your research and rationale of your solution. In pages 5 and 6, we'll talk about the details of the solution so that it will be well understood by the audience. In pages 7, 8, and 9, this is the place to show the conditions and the results of evaluation. Evaluations are very important. Simply telling the idea would not make a good paper. It is always accompanied by good evaluation, reasonable evaluations. And then in the last page, page 10, you will be presenting conclusion or summary. So this is a page allocation. However, please do not start from page 1. Page 1 is actually the most difficult part. So I'm going to talk about how you can prepare the order of slide preparation. The easiest pages are pages 5 and 6. Very easy. Details of the trick or the for the value. So this is the brief of your research. You are the person who has done it, so you should know this part best, much better than others. So this is that's why this is the easiest part. So let's start with the easiest part and then move on to the point and the rationale of the trick. Okay, trick is something new which you introduce in your solution, and the value is an advantage your research is giving to the user or the reader. Okay. Next, page 3, problem of the conventional method. Once you have talked about the point of your research and why it works, why you used this trick, it should be easy to describe the drawback of the conventional method or the problem. And then, naturally, it should be clear at this moment what is the conventional method or what is the state of the art, what is the most relevant research to your presentation, to your paper, all right? And then pages 7, 8, and 9, you will describe the conditions and the results of the evaluations. And then you can come back to page 1, background. Having written all these things, it should be easier for you to write about the background because you have a good overall picture of your presentation of your research, okay? And then finally, page 10 is used to conclude or to summarize your paper. Now, okay, this is what I have talked about. Now, key to a success. I said a combination of a problem and a value. The pair of these two things is very important. This is the key to your success. To help identify what is the problem and what is the value, I have been suggesting to perform 3-point analysis. Okay, you will follow these 3 steps. The first step is what is the value? Identify the value of your research. Value means something first in the world. If it's not first in the world, somebody else has done the same thing, and then your paper does not have a value. So if you have a good result, and if you are writing a paper, that means you have done something first in the world. You have achieved something first in the world. That is the value of your research. identify it. It may not be easy sometimes. It does depend on the description, how you describe it, how you look at it. What you have done would not change, but you will talk about it in many different ways. Try to find out what is the most impressive way, what is the most effective way for the readers, for the reviewers, for the audience. That is the first step. Okay, find out the value of your research. The second step, find out the solution. What is the solution? What is the solution you have used? Or in another word, trick. What is the trick which made this value possible? What brought this value? What kind of new things have you introduced into the method or into the material or into any process? So this is the second point. Okay? This is indispensable for the value. It may be a function, it may be a structure, it may be a component, it may be a process, or even an ingredient. Okay? So the third step, now it's much easier once you have done the steps 1 and 2. Okay? Identify the problem, which is actually opposite to the value. You are talking about the value. You have identified it already. Now it should be easy for you to find out what is the problem, because you have already talked about the value, and problem is just opposite to the value. All right? Just follow these 3 steps before start preparing for your slides. It's actually a part of slide preparation preceding your drafting. However, this is the most difficult part. As I said, the thing does not change. Your achievement does not change, but there are many possible ways to describe it, many possible ways to look at it and tell other people in the best possible way, in the most impressive way, in the most effective way. Okay? So ask yourself, once you have gone through these 3 steps, does the trick naturally remind of a solution to the problem? It does, again, depend on the description. You need to think about how you can describe the trick and the problem so that you will be able to answer yes with your confidence. Okay? Now, again, look at it. The first step, ask yourself, what is the value achieved? That's the first step. Okay, the value, again, important. Then ask yourself, what is the trick for the value? What kind of new things? What kind of new thing have you introduced when you have achieved your solution? Okay, that's a trick. And then the third thing, what is the problem which is opposite to the value? So number 3 is much easier than steps 1 and 2. And then you will go on to number 4, step 4. What is the conventional method? What is the state of the art? Having clarified these 3 things, value, trick, and the problem, and then it should be easy, it should be clearer for you what is the conventional method, what is the state of the art, what is the most relevant research to your paper, to your presentation. Okay? So once you have followed up to the 4th stages, and then the next thing you are supposed to do is to put the problem of the conventional method and its description, of course, to the second last paragraph of the introduction when you write a paper. And then in the introduction, in your paper, just trace back with the research history to the beginning of the introduction. So in another word, you will be describing the research history in the relevant field in the chronological order, starting with the oldest thing, and then as you proceed in the introduction, you will be talking about newer things, newer research results. Okay, so that's what I'm saying here. And then in the first paragraph of the introduction, you need to attract readers, you need to attract the audience. So let's talk about applications with respect to our daily life. I'm talking about the engineering case here. So if you are working on science, it may be somewhat different, but even science would benefit human beings in some sense. So you should be able to write something general in the first paragraph of the introduction. But in engineering, definitely you should do it, because engineering is to benefit our lives. So there should be some useful applications. Otherwise, it's not engineering at all. It is science. Okay? I'm not saying science does not have a value. Science has its own value. It is very important to establish a clear and comprehensive logic or the theory. That's what the science is. Engineering is to benefit yourself. Okay? That's the difference between engineering and science in the way I understand. Now, after having done that, this is how your introduction looks like in your paper. When you have done your paper, when you have drafted your paper, this is a single page usually devoted to the introduction. In the first paragraph here, you will describe how the value benefit the daily life. So this is the application part. And then in the second and the other paragraphs in between, you will describe the background, paper position with past papers. Okay? In these paragraphs, in green here, you will be describing these three things, A, B, and C. A is who and when did what and how it was. This is about an old research. And then the second point, B, its features and contributions. What kind of good things it has done goes to B. And then in C, you should also mention an unsolved problem here of the research you are describing in this paragraph. You may want to repeat this box a couple of times like this. However, when you come to the second last paragraph here, you should describe the most relevant research and its problem, as I have talked about in the previous slides. Okay? In the real last paragraph, this is the place you are going to summarize your research in a single sentence, in the first sentence, I mean, and then you may also add some introduction to the whole structure of your paper. Okay? So this is how an introduction should look like. All right? So let's get back to the three-point analysis. It's very difficult unless you have done it a couple of times. So as I said, the first thing you should do is to identify what is the value of the paper. The second thing, what is the trick to achieve this value? What made it possible? What made this value possible? A new trick. And then the third point, what is the problem you have solved? As I said, a combination of this value and the problem, they should be opposite to each other. That's a good logic. And then once you have done that, once you have performed this three-point analysis, it should be easy to design the title of the paper using the outcome of these three steps. And then you can also design a good topic sentence of the abstract. Topic sentence is the first sentence of the abstract to describe what is your paper all about. So this is actually the most important sentence in your paper, because reviewers and readers, everybody reads it for the first time. Okay? And you can again clarify what is the most relevant method, what is the state of the art for your research. All right, so I have prepared some helpful sheets like this to perform three-point analysis. The first one, let's identify the value of your paper, what is the first in the word? Ask yourself. Okay? And put it in this box. There is only a single line, and as I write it here, the font size here is 36 point. That's a huge font size. That means I'm intentionally saying this. You cannot put many words here. Naturally, you need to refine. You need to sophisticate your expression by choosing most appropriate word, most appropriate way of saying this, and removing any redundancy. Otherwise, it doesn't fit. You will notice it if you try with your paper, right? So put it here. What is the value of the paper? I will show you some example later so that you will have much clearer idea. And then do it here. What is the trick or a function to achieve this value? This value has already been identified in the first step. Again, put it here in the same size of a square. Again, it's not an easy task. You need to think about how you can describe it in a good way. And then, following these two steps, what is the solved problem? Again, I have the same size of a square here. So think about how you can describe it in the best possible way using 36 point. Okay? So once you have done that, no, I'm sorry. This is to show how you can identify the problem. Now, you have identified the value. To identify the problem, the first step I suggest is to put with no or not, to deny it. Because A is the value. Okay, value is something good, advantage, right? If you put no or not, it will be a possible problem. And simply putting no or not, it's very easy. You can automatically do it. So that's why I'm suggesting it. Okay, put it here, and then read it. If it's not a natural expression, you may rephrase it. But again, you need to keep everything in this box. All right? Sometimes this expression, box E, does not exist because this is good enough. Once you have done that, you have clarified A, B, C, and now D. A is the value, B is the trick. Now that you have identified A and B, it's easy to design a good title of your paper by combining A and B in the order of A before B or B before A. Either one is more appropriate. And you may use up to one conjunction. Now, B has this length, A has this length. You need two lines in this case. That's quite natural. You don't have to shorten any of these. And if it will make more effective, much clearer, you may want to add C to make this title better. All right? I will show you some examples so that you will have much better idea. Now, a good title of your paper has been designed. The next thing is to design or establish the topic sentence of your abstract. Think about the first sentence of the abstract. Sometimes you need to spend lots of time without knowing these things. I have done that when I was young, but now I can do it automatically. The topic sentence, you simply need to put some words before the paper title. Isn't it easy, right? So you have identified, you have designed a title of your paper. Why don't you put this paper proposes or this paper presents? Simply do that. which will make a good topic sentence, the first sentence in the abstract. So you will simply copy these two boxes from the previous page, and you can make a good topic sentence, very easy. Now, what is the most relevant conventional technology? What is the state of the art? It should have been clarified in the process of following the previous steps. But now, let's make it clear. Let's confirm it. Just write who is the first author of the literature and beginning of its title, and then where it appeared in journals and at conferences. You can reconfirm these things. Okay? Now, I'm going to tell you an example. These guys are Nobel laureate. They received the Nobel Prize in Physics in 2014 about their contributions to blue laser diode. And I am going to concentrate on the contribution of this guy, Professor Nakamura, who is now teaching at the University of California in Santa Barbara. So this is his contribution. What he was doing, he was working on MOCVD for short, or metal organic chemical vapor deposition. This is not my own field. I'm not very good at it, but I can understand by performing three-point analysis. What is the contribution? What is the value? What is the problem? What is the trick? Okay? What he was trying to do is to grow a crystal film on a substrate in a reactor. So you can control the temperature inside this reactor. It's something like an oven, which you use for cooking. But you will not cook anything in this oven, but you will try to melt ingredients to mix them or generate some vapor in it. So that's what this reactor is. You are supposed to put the substrate, that is usually a semiconductor, and then put some reactance gas. In this case, it's niobate and helium niobate, reactance gas into this reactor. And this gas is supposed to touch the substrate to grow a crystal film here. However, what happens here is that this gas does not go straight down to the substrate. Actually, instead, it does not touch the substrate. It is not delivered to the surface of the substrate. So this is the problem. Now, there was another guy, not the Professor Nakamura, Professor Koide. He presented a paper in 1986. He proposed a solution, that is an introduction of a delivery tube. He introduced this tube to carry this reactance gas to the surface of this substrate so that the gas is conveyed to the substrate, and there will be a crystal film deposited on the surface. This is his solution. However, when you look at this reactor, you need this delivery tube, which makes this reactor structure more complex. So it is not that good, but it is useful. He could use high quality crystal film here. Okay, let's perform three-point analysis on this idea. Now, what is the first in the world? Professor Koide, he was successful in MOCVD for blue laser diode crystal. That is first in the world. Until that time, there was not sufficiently good crystal fabricated. What is the trick or function to achieve it? Yes, it's easy. He introduced a delivery tube to carry this reactance gas. All right? And what is the solved problem? It's easy, it's opposite to the value. I said they are opposite to each other. And I also said, why don't you put no or not to identify the problem? So simply putting a no here, no deposition of blue laser diode crystal. Okay, so here, blue laser diode crystal was the value, no deposition. This is the problem. What is the opposite to A? A is the value. So I just put no deposition for blue laser diode crystal. And it works. Because this is just a noun phrase, I just rephrased it. Blue laser diode crystal was not deposited, which is a problem here. Okay? So there was a guy in Toyota Car Manufacturing Corporation, Taiichi Ono, who was a former executive deputy president. He is said to be the father of the management system within Toyota for production management system. He is said to be the father of that useful system. And he said this way, find the root cause of the problem to fix it. Once you have a problem, try to find a cause, but not only a cause, the root cause of the problem. How can you do that? So usually you try to analyze a problem to find the cause. Okay? So you need to go further and further. That's what he said. Okay, let's think about what is the cause for the problem in case of Professor Koide. The problem was crystal is not deposited. That is the problem. And the cause one, what is the cause? Reactance gas, which is sent to the reactor from outside, is not delivered to the substrate. It doesn't touch the substrate. And his solution is to introduce a delivery tube so that this tube carries the reactance gas to the surface of the substrate so that it will touch the surface. There will be a crystal film. Okay, so this is the solution which was proposed by Professor Koide. Now, Professor Nakamura did not stop here. He went further. He introduced a pressure gas. Why? He thought it in another way when he looked at the problem. Okay, I will explain why he could arrive at this pressure gas solution. Of course, this is a neutral gas and it doesn't do anything. It will simply press the gas from the top to the bottom so that the reactance gas sent into the reactor will not go up, but instead it is pressed down to the surface of the substrate so that it touches for sure without a delivery tube. The structure is much simpler than the previous idea with a delivery tube. So that's why this is better and it's worth Nobel Prize. Now let's perform the same analysis. The problem is the same. The cause one, this is the same thing. And Professor Nakamura thought, why reactance gas is not delivered? So this is the second step analysis to find out second cause. And he found that reactance gas goes up. It's lighter. That's why it goes up. So his solution is, because you would not like this reactance gas to go up, you can press it down. It's very simple and just opposite to the problem, just opposite to the second cause. That's why this solution is very good, very natural. That is how you should proceed. Okay? And the solution is gas delivery by pressing gas. He has introduced pressing gas so that it is guaranteed for the reactance gas put into the reactor to touch the surface of the substrate for the growth of a crystal film. Okay? So these things are important. Second why and the second cause to reach the root cause here in this case, and much better solution by pressing yes. Okay, so do the 3-point analysis in the same way. The difference is here. What is the trick? Pressing yes. That is the trick, right, in this case. And the problem is the same, and the value is the same. But maybe you can point out the value in this way. The reactor system structure is simpler than what was proposed by Professor Koide. So it does depend on what is the most relevant research, how you look at it. Okay? So to identify the problem, you can simply put no, and we have done it for the case of Professor Koike, and I just skip it. Once you have done the 3-point analysis, now it's time to design a good paper title. These are typical patterns of papers in signal processing, but it may be different in your field of research. You have already identified the value and the trick, so it's very easy to design a good title in this case. So first in the word, you put it here. This is the value, and then followed by trick and function to achieve it. So the title of the paper, by combining A and B, that's the value and the trick. MOCVD for blue laser diode crystal with pressing gas. Okay, pressing gas is the trick, remember. And if you add something more to make it clearer or make it better, I just introduced the word deposition here. So MOCVD for blue laser diode crystal deposition with pressing gas. This is a good title of the paper. And then the first sentence of the abstract, just automatically put these words before your paper title. This paper proposes or this paper presents MOCVD for blue laser diode crystal fabrication with pressing gas. Okay? So it's very clear, and it has specific word here for the trick. That is an example of a good title. Okay? So this is what is the most relevant research that was made by Professor Koide. Now, from here, I usually talk about the structure of the paper, but because of time constraint, I just skip it because you are familiar with what are contained in the paper. Okay. Okay, this page is probably worth presenting here. You may have often chances to write a very short paper like a single page or 2 pages. In that case, you have a problem to put everything you want into these small number of pages. Especially writing an introduction for such a paper is very, very difficult unless you are very experienced. So I have a guideline here. If you had the chance to write a very short paper, let's assume you have 3 to 4 sentences for the instruction. In that case, what is the first sentence of the introduction should be? Okay, so you should describe what has been presented as a conventional method. So in the first sentence, you will mention what is the conventional method, what is the state of the art, or the most relevant research to your research. Okay, so that's the first sentence. Describe it with the advantages and the reference. Okay, don't forget to put the advantage by this method. The second sentence is used to describe what is the existing problem. So you have already described an advantage or advantages of the conventional method. Now it's time to describe its problem. And then in the third sentence, what is the topic of the paper? This is just like the topic sentence of the abstract. So it should always start with this paper proposes or this paper presents, followed by the paper title. It's very easy. So the last sentence is just automatically assembled here. Once you know these techniques. When you have a chance to write much longer papers, and then each sentence will form a single paragraph, you will put more detailed information about each sentence so that you will be able to make a sufficiently long paragraph. Okay? Now, let's skip these things because I would like to spend more time on presentation. Okay, this page is also worth presenting here. Don't put too many contents in a single sentence. Don't try to say too much thing in a single sentence because it will make a kind of twisted sentence, make it hard for the reader to understand. Always try to make sentences simpler. And then avoid use of multiple ofs in a single sentence. Sometimes, especially when you have a long sentence, there may be up to 3 or 4 ofs, and you will not understand which of it is and what it actually means. So use short sentences and try to avoid use of of more than twice. Up to twice may be necessary, but in all other cases you can rephrase it so that you don't have to use an of. Okay? And avoid redundant expressions. Sometimes we see this kind of expression like, this reports, they come from the same root. So this is a kind of, redundant expressions, and you feel quite unnatural when you hear it or when you read it. All right? Acronyms. You are likely to use acronyms represented by some alphabetical characters, like 3 characters, 4 characters, like that. Acronyms should be fully spelled out at its first appearance. When you use it for the first time, fully spell it so that there will be no misunderstanding. In signal processing, we often use fast Fourier transform, FFT for short, but in another field, FFT may be used for another meaning. I don't know. So whenever you first write FFT, put full spelling of this acronym. But in that case, there may be a problem or question may arise. Actually, this is my question. When I was in my late 20s, I was taking a technical writing course. I gave a question to the instructor. Which way should I use? FFT, that's the acronym here, followed by full spelling in parentheses. Or first show the full spelling followed by the acronym in parentheses. Which is correct? Which do you think is correct? If you think the first one better, raise your hand. If you think the second one better, raise your hand. Okay, thank you very much. So most people like this way, but it does depend on the case. That was the answer in my young days. And I keep saying the same thing. It's clear. The rule is very clear. Yes, this is fine. This is looks quite general, but sometimes this is better, and you should use it when this acronym is widely acknowledged. For example, in signal processing, everybody knows what FFT is. People even don't say fast Fourier transforms. They simply say FFT instead. So in that case, this is more general expression, and it's okay to put an acronym first, followed by the full spelling in parentheses. So that's why I said it depends, and that was actually the answer from the instructor of the technical writing course I was taking in my late 20s. Okay, so this is worth remembering. Now, I have some examples of traps, but I will also skip these because of the time. Now you may feel that you can write a good paper, but sometimes there are traps, and it's not always that easy. Okay, before submitting a paper to a conference or submitting to a journal, ask yourself these 3 things, important things. What is the value of the research? In what application? Is it clearly written in your paper? Second question, what trick makes it possible to achieve that value? Is it clear? List all components for the value, not only one trick. Sometimes you may combine 2 tricks to achieve your value. In that case, don't miss one of them. Put both, all right? And how good is the trick? That means always show the evaluation. When you have performed the analysis, you are supposed to show the evaluation with some pseudo data or real data from the real world. Otherwise, you cannot prove that your analysis is correct. Okay, there are some tips. I found it very useful, and I have been suggesting to do it, everybody. Build your own dictionary or thesaurus. It's different from a field to another. It's different from a person to another. So you should prepare your own and then always refer to it and always try to use it as often as possible so that it will be part of your capability. Consult with the dictionary when you see or use a new expression or unsure expression or usage. Make sure that it is correct. To do that, you need to go to the internet or you need to go to a printed dictionary. In that way, you can build up your knowledge, very good knowledge. And I often have a question if it is necessary to have an outline of the presentation. And the answer is sometimes yes, sometimes no. When it's not necessary in general research presentations, because everybody follows the background and the proposed method, the evaluations, conclusion. So it's clear. In that case, it's not necessary to show the outline. However, it's another story. For example, like this, presenting something else. This is not original research. It's a kind of tutorial. It's a kind of overview. In this case, it's not easy to expect what comes up next. So in that case, it may help to put an outline before you will go into your actual presentation. Okay, so this is the answer to this question. Now, these are summaries. I talked about easy technical writing. You can make yourself lazy too. Start with slide preparation. And before preparing slides, perform 3-point analysis to clarify the value, trick, and the problem. And then you will have a good logical structure. Once you have prepared your slide, 10 to 15 pages, based on these slides, you can start drafting your paper so that your logical structure has already been established in a good way in the slides. And it is guaranteed that your paper will have a good logical structure. Okay? So that's the summary of technical writing. And then I am going to talk about presentation, how you can make a good presentation material. I am going to talk about these things very briefly. So the first thing is don't put sentences in your slide. Okay, putting sentences makes your slide more congested, more crowded, not easy to read from a distance. Okay, so this is a good example. Don't put a sentence. I have no sentence in this slide, but it is possible for me to convey the idea. Oh, maybe something is missing. Oh, this sentence should be placed here. I don't know. Maybe because of the difference in the word version. Okay, and between the keywords you can connect by your talk. So you don't have to put the whole sentence, but just connect the keywords by your talk so that redundancy can be fully eliminated. Now, use big fonts. I said the minimum size of the font you are supposed to use is 24 point or greater than that, so that it should be visible from a distance, like the last row of the room, especially when the screen is small like this. Sometimes you have a huge screen, but in that case, you may be put in a huge room. So always you have this problem, font size problem. If you can't read it, nobody will concentrate on your presentation, right? So it's very important. This is the first class technique, real basic technique. The first thing you should follow, okay? And then also use Gothic and bold fonts. Why? Because they have the same thickness in the horizontal lines and in the vertical lines. Some fonts have different thickness, and wherever the line is thin, it is not visible. So that's why it is recommended to use these fonts. Now, eliminate redundant space. If you had much space in your slide, that means you are using small fonts. Try to increase the font size, okay, so that it will be more visible. And even if you have open space after increasing the font size, don't put more information, unnecessary information, I mean. Okay, try to rearrange your slide by combining the current page with the following page or with the previous page, so that it will be much better. Why not use colors? It's very useful. It's very effective to convey the information when you use the color. Emphasize the point by color. For example, I'm using red to emphasize important points. And also pay attention to color combinations, as I will talk about in the following page. So bad examples. Okay, black font on a dark color. It's not easy to read. It should appear this way. It's better than this one. And avoid pale yellow or pale blue with a white background. Not easy to read. But you may want to use these specific colors. What can you do? Introduce different background color so that you can stick to your favorite colors and make the presentation visible, much easier to read from a distance. Okay, so this is a technique. Appeal to the site. Instead of writing things this way with the tens of words, you can convey the same information or much more information if you introduce a graph like this. Illustrations, graphs, they would help a lot. Always try to introduce an illustration or use a graph instead of a table, as I will explain it later. Okay, so table to figures. Many people use many tables to show the results, to show the performance. That is not recommended. Not easy to read, as I will show it. Okay, so the purposes of a table, there are basically three. Compare things by number, compare things by character, or to list items. To compare by number, compare the result by number, use a graph instead. In these two other cases, you may keep the table because a table is useful in these two cases. Okay, so these are the examples to keep the table. You may keep the table for evaluation conditions or parameters to show, or to compare multiple methods by listing, or method and features comparison by character. So in these cases, you may keep the table, but otherwise transform a table into a figure. I'm going to talk about how you can do that. The figures are friendly. That means easy to read. So there are three components for easy to read. The first one, graph is much easier to read than a table. It is not necessary to think which value, I made a mistake here, which value means what. You don't have to think about it if you had a figure instead of a table. And then value comparison actually takes a time in the table, but it's straightforward. It's clearer in the figure. For example, here is a table with numbers. Okay, it's not easy which value means what to understand and compare the value. The message of this table is unclear. I am going to show how you can convert it into a figure. Okay, minimum of the line of sight. When you look at some place, try to identify the message. In the table, you need to change your line of sight and refocus it. It's not easy. It's tiring. So that's why it's not recommended. The third one, figures are more intuitive. It's not necessary to convert. You can read the meaning directly from a figure. Okay? So figures for continuous changes, you can use a line chart like this. These are the examples along the time axis here, and continuous change. You may use a line chart. To show ratios, you may use a stacked bar chart like this, or you may use a pie chart like this. In case of relative values, you may use bar chart like this, or it's not necessary to put the vertical bar chart. You may tilt it by 90 degrees to make use of your given space more efficiently. So this is okay. It's another bar chart, even though you may not have seen it many times. I often use this one because sometimes this type of bar chart is too narrow and too tall. You can simply tilt it by 90 degrees so that you will have the same information in this form. Okay? So when you prepare a figure, put a label for axis. There are some people missing the labels like these. So always try to put labels so that these axes are becoming clearer. And the scale font size so that it will be the same size as the body font size or even larger. It is often possible to see a very small font size in figures compared to the body of the paper. It's not easy to read it, and then in that case, reviewers do not read it. And then your paper will be rejected very easily, whatever good result you are showing in the table. Okay? So very important point. Use 24-point minimum. That's a golden rule as I keep it repeated, as I say it repeatedly. Okay? Like this. Font size. Not like this. Actually, this is a direct copy from Excel. Just replace the labels so that it will be visible like this. You should not be able to read these from a distance, but it should be possible to read these. Okay? So sometimes you may decimate the values. Okay? So you don't have to put all the numbers at each notch. You may skip one for every 2 notches so that it will be easier to read. That's another technique. Okay? And sometimes use different thicknesses. For example, to express a curve 3-point line, and to express frame, it's 2 and 2.25 point, and scale may be 0.75, and indication line like this may be expressed in the 1-point line. This is helpful. Legend in the graph can be taken into the graph itself. Here is an example in the case of the stacked bar chart. You have a legend here on the right side of the stacked bar chart. It is possible to include all these so that it will be more intuitive. You don't have to compare, you don't have to identify this color and find out where it is. It's here in this case, and here. It's more intuitive. You can save lots of time. Save time for the reviewers and the readers. You will give them much better impression, which leads to better acceptance rate. Okay, so, oh, it must be D, not legend. In case of pie chart, you can do the same thing. This is, the legend for this pie chart. You can also make it this way so that it will be easier to read. When it comes to a line chart, okay, here is the legend, and you can put it into the graph itself. There is a big open space here, and it will look like this way. It will be bigger. The graph itself is bigger, so it's easier to read. And sometimes it's also helpful to use indication line like these straight lines to show something specific, like a deep neural network, or DNN for short, is represented by this curve, or to group some lines. So these two trajectories are representing baseline method, and these are for the proposed method. So use these two techniques, line and grouping, efficiently. Now, let's compare an old style graph and a new graph which has been applied all these techniques. So this is the old one, the original size, not easy to read. This is how it should be. It's much easier to read, big fonts, and the graph itself is bigger compared to this one. This is how a figure should be. Now, there are some other techniques. Intuitive agreement of colors. Okay, so this is a line chart and showing some countries like US and Germany, UK, and so on. You can make it more intuitive by showing the country names in the same color as the line. It's more intuitive. It's very important. You don't have to go back to the legend. Now, table 2 graph, example 1. Very complicated table. This is an example I received several months ago from one of my colleagues, and I suggested to transform these two tables into a graph or graphs. It's not possible to understand what the message of these tables, but he actually wanted to highlight these values, but still the message is unclear. All right, the first point. Now, what is the message? What are the messages by the figure after transforming that table into a graph? So here are two conventional techniques. Here are some bars obtained by the proposed method. The point here, there are two messages. One is that, of course, the proposed method is better than the conventional methods. That's the first message, which can be expressed here in this way. There's yet another message by these bars, that is, the proposed method is insensitive to the value of rho. Whatever the value for the rho you are taking, the performance is almost the same. So it's insensitive. You don't have to pay attention to selecting a good value for the parameter. You can pick up one value, whatever you want, among 0.1 and 1.0, and use it. So it's very, very, very good from a viewpoint of industry. So how we can make it better? So the thing is that insensitive, this is the message. That means narrow range. You are showing the range is narrow. So let's integrate all these bars into a single one, mean plus range. Okay? What you are showing here is that they are almost the same. So you can show the distribution or the variance in a single bar chart. Okay? So this is an average bar. This is also an average bar with the distribution. So these are the ranges. You can still show that the ranges are narrow and insensitive to the selection of the row. Right? This is a special case, so it's eliminated here. Now, let's compare. Let's look at the new graph. The number of bars, it used to be 8, now it's 4. Only 4 bars, 50% reduction is much simpler, and easy to read and compare with no loss of information. There's no information loss now by reducing the graph, but you can still receive the same message from this new graph as the message is given by the original graph or by the original table. Okay, so there is the effect. Now you can apply the same technique to another table. That's the improved one. Now example 2, now this table shows the necessary offset value. So if we convert this table into a bar chart like this, now ordinate, look at the ordinate. They are not aligned, even though they show the same measure, offset, values of the offset. In this figure, they are showing only negative values. In this figure, they are showing positive values. And naturally, they have some relationship between these. So what are the messages again? Better than the conventional, insensitive to row, and onset and end point, small necessary offset for the proposed method. So the message is to show the required offset is small. So let's integrate these two figures into one with the time in the abscissa. So this is the result, much easier to see. The time goes to bigger value in this direction. If you go in this direction, it becomes negative. So you are going back into the past. And showing the values here, you are showing that the difference is very small, but still the proposed method has very small distribution. That is a sign of insensitivity in the selection of the value of rho. In this case, the difference is much clearer. Okay? So the point is that let's align the axis. In this case, this is now the time axis for both figures. Okay, so you are going to check these points. As I said, this is most important, minimum 24 points when you prepare a slide. And then you can also check all these things. Now, you can also check these things when you prepare a figure or when you have completed the figure. Check these one after another so that you have prepared a good figure. Okay, so here is a summary of slide presentation. Don't put sentences, use words instead. And between words, you can connect them by your talk. And no redundant space. Why don't you use bigger fonts if you have redundant space? And use Gothic and bold fonts. Pay attention to the color combination so that they will appear in a better way. And let's appeal to the site instead of putting equations or things like that. Just try to use an illustration. And then finally, I also have shown that pay attention to the chart type, line chart, pie chart, bar chart, things like that. Okay, so this is an overall summary, but I will not go again through this page because I would like to keep time for questions. All right, this concludes my first presentation. It's now your time to give me questions. Thank you.